So we're going to start today by looking at confidence intervals for a single proportion. And to begin, we want to recall something we talked about in the first semester, which was margin of error. Remember, when you're taking a survey from a sample, that sample is representing the population as a whole, and the proportion of respondents that you get to answer a particular way, you're not necessarily saying that that's exactly what's happening in the entire population, but you're pretty sure that it's within certain boundaries, and that's what the margin of error is. If you recall, we said the equation for margin of error is 1 divided by the square root of n, where n is the sample size. So you know that the bigger the sample size, the better that sample is at estimating that true proportion. Okay, a margin of error goes a little bit above and a little bit below. So let's say that you had 60% of your sample favoring candidate A in an upcoming election, and the sample size was 100 people. 1 divided by the square root of n, okay, square root of 100 is 10, so you're looking at a margin of error of 1/10 or 0.1, so that would mean that your confidence interval would say you believe that 60% with a margin of error is going to be between plus or minus 10%. You're pretty sure between 50 and 70% of that population favor that candidate as a whole. Okay? Now, it turns out that that was a little bit of a shortcut for a confidence interval. A confidence interval is pretty much the same idea, but we have a little bit more understanding now of where these numbers would come from. So we also want to consider something that we looked at initially in the first semester, but we've seen it here and there ever since, and that's the idea of the empirical rule, that within 1 standard deviation of the center of a normally distributed set, we have 68% of the data. Within 2 standard deviations, we have 95, and 3 standard deviations is 99.7. So it turns out that we're going to be using this 95 quite a bit. It's a pretty good compromise between a relatively safe boundary from where your sample value is, and it's a fairly high level of certainty. If you're 95% confident, okay, 95% is like 19 out of 20 times your value would be within that interval. So that turns out to be a pretty good estimation, or a pretty good rate for success. So most of the time we're going to use a confidence interval. It's going to be at that 95% level. A confidence interval, you can see, is an interval of values computed from sample data that is almost sure to cover that true population proportion. We usually use that 95%. So what we're saying is that we're willing to take a 5% risk that that interval does not actually include the true value. Okay? There's a certain amount of time, 5%, that we would take a sample and it would not be within this interval. Okay? We never know for sure whether any one given confidence interval includes that true value. However, with the law of large numbers, in the long run, 95% of all confidence intervals tagged with that 95% level of confidence will be correct, and 5% of them will be wrong. Okay, we are expecting to be wrong sometimes. Now let's give you a couple examples of when confidence intervals are used in the media. Typically you will see that 95% level of confidence, and margin of error is essentially the same thing. So when you see those words margin of error, what they've done is calculated a confidence interval to go along with that. Okay, so you're taking your sample proportion, whatever proportion of the sample either agrees with this or favors this candidate, plus or minus that margin of error to create the interval. So in the early 2000s, Sacramento, California, the newspaper there, the Sacramento Bee, reported on a poll done by the Pew Research Center that 54% of respondents agreed that gay and lesbian couples could be good parents. Now, the report also provided a little bit of information about that. The sample size was a little over 1,500 U.S. adults, and the margin of error was 3 percentage points. So, what proportion of the entire adult population at that time would agree that gay and lesbian couples could be good parents? Well, with that 95% confidence interval, okay, if we were to calculate this, that we take that proportion of 54%, that goes right there at the center of the curve, okay? And a 3% margin of error, 3 below would be 51, 3 above would be 57. So what you're saying is that you're 95% confident that in the entire population of U.S. adults at that time, in 2003, thought that gay and lesbian couples could be good parents. Particularly important here is that that entire interval is above 50%, indicating that we do have a majority of American adults that at that time believed couples, gay and lesbian couples, could be good parents. It's not enough to just have that sample proportion above 50%. We need the entire interval to be above 50%. Because again, you're not concerned with what that sample says. You want to be able to use that sample to say something about the population as a whole. Another example, in the 80s and early 1990s, the United States and the world as a whole was experiencing an epidemic at that time with HIV and AIDS. And kind of like what we're seeing right now with COVID-19, there was a lot of uncertainty. Exact numbers were unknown, and people were trying to get a grasp on the data to be able to make some predictions and some estimates. So when that data started to come in, we see this excerpt here for the first time. Survey data is now available on a randomly chosen cross-section of Americans conducted by the National Center for Health Statistics. It concludes that 550,000 Americans are actually infected. But at that time, some estimates for the number of individuals affected with AIDS had been as high as 10 million people. But the CDC had estimated the number to be about 1 million. Could the results of this survey rule out the fact that the number of people infected may be as high as 10 million people? Well, this doctor, Geraldine McQuillan, said that the statistical margin of error in the survey suggests that the true figure is probably between 300,000 and just over 1 million people. The real number may be a little under or a bit over the CDC estimate of 1 million, but it is certainly not 10 million. Right? So we're given essentially a confidence interval here ranging from 300,000 to 1 million people. But to get a number as high as 10 million, that is far beyond the scope of that confidence interval. Finally, kind of giving some credence to some actual values, that you're not getting these outlandish estimates of 10 million that had been there before accurate data was available. Our last example for the day is looking at the Environmental Protection Agency. They said that there is a 90% probability that the risk of lung cancer for passive smokers is somewhere between 4% and 35% higher than for those who aren't exposed to environmental smoke. So sometimes you hear about passive smoke or environmental smoke referred to as secondhand smoke. To statisticians, this calculation is called the 90% confidence interval. Now, remember, I just said at the beginning of this lesson that almost all of the time you see a 95% confidence interval used. And that's what the tobacco companies tried to call out this study on. Okay? The tobacco company statisticians said that 99% of all epidemiological studies use a 95% confidence interval, said this person for the Health Policy Center in Bethesda, Maryland. Okay? So they weren't questioning the numbers necessarily, but they were questioning, well, why is a 90% confidence interval used? Okay, a lower level of confidence. They were trying to call out the EPA on that statistic that isn't normally used. Now, the EPA noticed this, and the problem was that they used a 90% confidence interval because the amount of data available at the time did not allow an extremely accurate estimate of the true change in the risk of lung cancer for passive smokers. The 95% confidence interval actually went below 0%, indicating that it's possible that passive smoke reduces lung cancer. Now, they thought that that was pretty straightforward, but in order to eliminate any possible confusion about that, okay, we know that a 95% confidence interval, you're going to increase the width of that interval, meaning that it would dip into negative numbers. We saw an example of this in our last lesson when we were talking about the average weight loss of those individuals at that weight loss clinic. We had seen that the standard deviations going to the left went into the negative values, meaning that a negative weight loss meant that you actually gained weight. So you're talking about that double negative here. That's the same kind of confusion that they wanted to avoid here. So rather than deal with that and try to explain that, they just said, well, instead of a 95% confidence interval, let's just go with 90, and you're able to decrease the width of that interval. Okay. The EPA believes that it is inconceivable that breathing in smoke-containing cancer-causing substances could be healthy, and any hint in the report that it might be would be meaningless and confusing.